Thank you. I would like to talk about AI, some of our own experiences with Sentient. I will not talk about Siri. Hopefully give you a little bit of a different perspective on where AI can be used. We've all heard about how AI could be huge with big data and so forth. But there are other areas as well where AI can come in and help. And I'll spend more of the time talking about AI and trading, but talking a little bit about other application areas as well. At Sentient, I'm a co-founder and CEO, and we decided right at the get-go in 2008 to be an AI company. Back when, I like to say in 2007, a book was published about the future of everything and not a single mention of AI. So we've gone through a lot of cycles of promise and lack of delivery around AI, and we're in the latest one right now. Although somewhat justified, I would say. The confluence of three things has made AI quite uniquely well-suited for our current needs. One is obviously a lot of people are collecting a lot of data. And our first inclination is, how do we use this data? And maybe there are patterns in this data that AI can discover for us that we can't find ourselves. The second is cheap compute and cheap storage. Makes it easier for us to run AI at scale. But that is not enough. There's a third leg of the stool, which has to do with the algorithms themselves. There have been breakthroughs in AI algorithms. The most famous is deep learning, which is probably the best rebranding ever in algorithmics because it is neural networks. It's just rebranded as deep networks because they can afford to scale it. And by deep, they mean hundreds of hidden layers in neural networks that hopefully some of you guys have been familiar with. Neural networks were in the lab for the longest time, but now they can be used in much larger applications simply because of the scale. So it is these three: big data, lots of compute and cheap storage, and the algorithms themselves scaling so that we can use them. So where do we use them? Where do we apply them? The reality is that AI today is very similar to computing in the early 80s. Where everybody was thinking about computerizing. I don't know if you guys remember that term. And enterprises actually had computer departments. That's laughable today. Every one of us are computer experts by those standards today. And I think that's where we are going with AI currently. So as Sentient, we did have a choice. We had some pretty groundbreaking technology. We could have gone down the route of IBM and become a consulting shop or put out the technology as a platform and teach other people to use it. It's not very simple to use AI. AI is hard. And so what we decided back in 2008 was to actually be a product company. And so I'm going to talk about three different products that are based on AI. They get their differentiation based on AI. But the AI has a subtle role that is really not something that you notice right off the bat when you see it. The three areas that we decided to go after are in finance, e-commerce, and digital media. And I'll show you some examples of all. But essentially, as I said, the AI is the fundamental differentiating factor in the products that we've created there. So let's start with e-commerce briefly. Shopping online has not changed for the past 10, 15 years. If you know what you're looking for to buy, you need to know exactly how it's referred to by the manufacturer, which is not very obvious. And if you don't, then you're faced with pages upon pages of images to scroll through. So how do we AI enable e-commerce, what we call, or my marketing department calls, intelligent commerce? How do we bring that about? Well, if we take AI and have it perceive the catalog of what is being sold, just like a human would perceive it, then that AI could sit between the users and the catalog and help the users navigate to what they're looking for. Notice what is happening here is I'm not tasking the AI to go look at historical data. It turns out the most effective way to know what a user is looking for is their current context and their current interactions, not what other people like them did before, and not even what they did before. An example I use is, I researched a car for a couple of hours a year ago online. And up until recently, I was getting ads for that exact make and model. I've bought that car. I have it for a year now. It's just annoying that I'm getting those ads. So there is a better way. I'm not saying that that data is not useful, but the current context of the user and the data that comes in here and now is much more useful. And so you can actually take the AI and have it be the shopping assistant. Just as you walk into a high-end store and a shopping assistant walks up to you, and through a few interactions they get a sense of what you're looking for, the AI can do the same for you. So let's watch a little video of how this works for shopping sunglasses. So first we will see how sunglasses, if you really want to, if you're a power user, how you buy sunglasses right now. You have this left-hand side frame picker, very complex. You have to click between the frame and the color and all that, and it's just a headache. Most users do not use that. The alternative is if you actually, in this case, are presented by the AI with some representatives of what is in the catalog. As you click through these representatives, the ones that come closer or have some aspect that's more interesting to you, the AI starts to home in on what it is exactly that you're looking for. Within a few clicks, you get to the frame that you're interested. The same thing if you have already found a frame that is interesting to you, but you're looking for alternatives to that. The AI can come up with that. These frames are probably very similar. Maybe you're looking for something that's a little bit cheaper, and the AI can interrogate its model for what's there, and in fact interact with other things. We just changed the color, and the AI changed its recommendations based on that interaction that happened outside of the system. So there's more examples. I'm going to skip through these now. This is a subtle way. We actually did some user testing to see whether we should have an avatar that stands there and say, "Hello, I'm the AI. Let's interact." And in fact, the conversion rate was lower. The user wants to be in charge, and this is the power that they get by the AI just subtly changing the user experience as they interact. The same now can be used in a mobile setting where a lot of money has gone into mobile commerce. Most of us use mobile much more often than online through browsers. But most of us don't shop. So the conversion rates in mobile are very, very low compared to online. And so here's a user experience now completely driven by the AI, because the real estate is so limiting that you can't even allow for example, a frame selector on the side and so forth. And this allows users, again, within a few clicks, if they know what they're looking for, to get what they're looking for, and also makes it a very pleasant interaction to search for, to get an understanding of what's available. By rolling this out to, e-commerce customers, what we've realized, there are three numbers that I'm going to quote to you. One is the conversion rate itself. Obviously, ultimately what we're looking for is, are we selling more? And the conversion rate does go up by 30 to 40% by introducing the AI like this. The other is the average order value. In fact, the average order value goes up. The reason for that is because the users are now finding what they're looking for, and they're falling in love with that item, and therefore they are ready to dish out that extra few dollars to buy it, so the AOV goes up. The most interesting stat, though, is the percentage of the inventory that is actually seen by the users. There's a famous anecdote out there that only 10 to 15% of the inventory of an e-commerce store is ever seen by the users. And this allows users to see more than 75%, which means that the inventory itself wasn't bad. It was just the fact that the user experience wasn't there for people to get to what they're looking for. Finally, in e-commerce, you can do what we call shop the look, editorialized content, and being able to break it down into what we have in the inventory right now that matches that look. So I want to look like her. Well, I don't, but someone might want to look like her. But you know, have some variations to the theme, or want to, you know, have a certain budget for what they're looking for. And in fact, even in store, that's helpful, because in store, often one of the problems they have is these mannequins are dressed in some certain way, but they run out of those particular items. So being able to recommend other items that are very similar to what the mannequin is already wearing becomes quite important. Okay, but this was e-commerce. Let's jump into trading. And I hope you can draw some analogies here with what I'm saying. Trading has been used in two different modes. Often when I sit in these panels and we talk about AI, one of the questions we get, which I think of as a loaded question, is, you know, will AI replace us, or is it complementary? And of course, they are nodding for me to say it's complementary. Well, not always. And in fact, AI in trading has been used in both manners. More so recently as a central algorithm to actually completely encompass the trading strategy. But further back in time, if we go even to the 70s, there have been a lot of AI-based systems that complement trading. Some of them I've listed here. Some are actually familiar, and but this is less interesting, right? Decision support systems, systems that help us with, for example, portfolio optimization. Today, what is really in vogue is actually having the AI itself drive the trading end-to-end. And so there are two classes of such trading algorithms: those that are inspired by the brain, neural network-based, and machine learning-based, and those that are actually inspired by evolution, survival of the fittest. The type that's inspired by the brain typically uses deep networks that are trained using backpropagation. In some cases, a lot of interest these days is around autoencoding, which means using systems that actually can discover features from raw data rather than feeding it features that we have somehow discovered in the past to be useful. So that's the track that's the most interesting. In the case of the e-commerce examples that I gave you, the AI is actually discovering features in the inventory. So if we're selling sunglasses, the AI is actually discovering that one of the differentiators between two sunglasses is the type of frame, being metallic or not, or the bridge, or even color. So the concept of color is actually discovered by the AI from scratch, because it is a very important distinguishing factor in the items that are being sold. The same could happen, and is hoped to happen, in trading. It's all about, can I find some feature in this data? Maybe it's just technical data based on volume and price that nobody else knows about, that can give me some indication of how this instrument is going to be priced in the future. So a lot of work in deep networks goes there. The other is evolutionary computation, and I would like to now talk a little bit about how that works. You might know from old genetic algorithms, but the fundamentals are very coarse adaptations of how we believe evolution works in nature. We have a concept of fitness. We need that in order to be able to put a relative value on candidates that we are looking at. So let's say the candidates we're looking at are traders, synthetic traders. We need to be able to measure one versus the other and say this guy is better. I'll talk a little bit about how it's kind of complex to do that in trading. And then what we do is we use principles of combination and mutation in order to move and build new candidates from existing candidates. So how does this work? I often get this question. It's difficult to answer it without using some visuals. And in order to use a visual example here, I would like to talk about the third product that we have, which is adaptive websites, adaptive digital content. Let's imagine that we have a very large number of possible websites that we can have for ourselves, different designs, right? And we want to come up with a design that's better, has, for example, a better conversion rate or click-through or what have you. So first step is let me determine what are all the possible number of designs available. So in that plane up there, it's like anything goes, very large search space. And the trick is I want to traverse this search space as quickly as possible, as efficiently as possible. So the first thing I do is I just throw darts randomly at the search space and come up with random designs, for example. And then I use my fitness function. In this case, let me serve it to some users and see how well it does, for example, on conversion, and measure that. Once I measure that, I can rank order based on the ones that did better versus the ones that didn't do as well, and pick parents in order to build the new generation. When I pick these parents are, of course, web pages, right? In this case, we have two, parent A and parent B. There's something about these web pages, we suspect, that made them better than all the other ones that we looked at, right? What is it? Well, we don't know. We can't pinpoint. It might be one change out of many that we've made. It might be a combination. So let's do a binary search on this possible website designs and actually break it down on combinations of these features. So in this case, I know that somewhere in this parent A, there are a few features that make it better, and somewhere in parent B, there are a few that make it better. So what if I actually built a child and put half of A and half of B in it? Chances are non-zero that I would have created a child that has the better combinations of features from parent A and the better combinations of features from parent B now in child A. Now, of course, I'll have to create more than one child because chances are non-zero that I get the bad combinations in there. As human parents, we never admit that, but that's okay. This is an analogy. So I build multiple children as I populate the next generation. And as I do that, I'm now searching in the vicinity of these parents that did well. And as I do so, I'm starting to search less areas. I'm more focused in what I'm looking for. And through multiple generations, I am finally able to find those designs that do better. In this case, we have a percentage, for example, on conversion rate with each generation that's improving. The other thing to notice here, is this a laser? Yeah. The other thing to notice here is these bunches here, these areas that automatically have divided my search space. And it's possible that each one of these have a combination of features that are in of themselves interesting. John Holland was one of the pioneers in genetic algorithms. I talked to him once about this, and I said, in my opinion, evolutionary computation is not about finding the best. It's about finding what is interesting. And he said, son, the rainforest does not search for the best. And so that is the case here. In trading especially, we are looking for diversified solutions. And the evolutionary system has an opportunity to actually identify those for us. He called me son because he was 87 years old or something. Okay, so let's look at a quick video of how this actually works in action for websites. So this is a website. The owner wanted to actually increase the number of click-throughs here for sign-ups. And we used evolutionary processes to do so. This design here is actually the baseline. It's the design that they already had in the first place. And what you're seeing here is as the AI is searching for new designs, we are getting better and better candidates that are the best candidate. But not just that. This blue line here is actually the average of the run itself, which means during the run where we were searching for a better design, we actually improved the performance. What if we could do something similar in trading so that as we were trading, we could adapt to what's happening and improve on the designs? And before we leave this, it's not very obvious that a human designer would have come up with a design like this, but it does increase the performance quite significantly. And within 8 weeks, we were able to improve the design by 45%. And during the run itself, the conversion rate improved by 12%. Only 450,000 users. So it doesn't take a lot of hits to be able to do this. OK, back to trading. I'll zap through a few slides here, just some sort of points about how we should go about building this AI-based trader. First of all, very, very important, let's have some benchmarks. What are the current, for example, buy and hold is a very good benchmark. Always use that. I read papers published in 2001 that claimed that no AI can beat buy and hold because obviously they benchmarked it against 98, 99, and 2000. So yeah, be careful how you pick your benchmark, but do have one. In cases of population-based systems, random walkers are very good baselines to use. Omniscient trader is a trader that knows the future. It turns out it's actually very difficult to code an omniscient trader. Even if you knew what's going to happen in the future, it's very difficult to come up with the best possible trading system. This is the fitness function. In machine learning, often it's called the loss function. I like to call it the fitness function, just looking at the half full. But in trading, fitness is not just returns, as you guys full know. It's consistency of returns. In fact, it's not just returns consistently. There is an aspect of activity as well. If I only trade one time, that's not good enough. I want to have more activity. And of course, trading and making money, if you're correlated to common factors or the market, might not be as interesting. The dimensions of this particular search space, unlike the one that we saw, which was just designs of a website, could be many. When we're looking at technical indicators, it's probably price and volume and some derivatives of that. But you could also include some fundamental indicators in there. And those make up basically the search space. And very quickly, that search space could be very, very large. And we'll talk a little bit about how it can be traversed. But very importantly is the data. The data needs to be as free of noise as much as possible. The question of do we have enough data cannot be asked enough times, especially through time. So it's very, very important. And clean data is super important as well. We learned this the hard way when we were still a small startup. We actually went and bought data from a cheap vendor, and they had not accounted for daylight saving changes, for example. So, for part of that historical data, the start of the trading day fell 1 hour into the day itself. And obviously, our system, the AI found that to be very interesting. Wow, there's no volatility, and suddenly there's a spike. Very important there. And then finally, you do want to account for overfitting. No matter what anyone tells you, AI does overfit, and you have to account for that. So there are some ways to do that we're familiar with in quantitative methods as well. Obviously split your data to seen and unseen. You can do cross-validation. I would recommend actually having a third unseen set called the evaluation set. Once you establish that you've generalized and it's met all of your thresholds for acceptability, run it on a set that is large enough that you do apply principles of differential privacy so that you don't dilute it or actually minimize the dilution of that set, because even unseen sets can be diluted if you run against them sufficient times. And of course, ultimately, running live. You can start running live, sort of paper trade live, like it's real time but fake money, and then gradually add real money. So let's walk through, just as the final part of this talk, let's actually build a system like that together. So we want to build a system that trades, and it encapsulates the entirety of this trading strategy. So it actually comes up with a strategy as to when to trade, what to trade, how to trade, what trading operation to use. So the first step is let's model this trader, and here's a very simple model for that. We have a bunch of rules. Each rule is comprised of a number of conditions. If these conditions are met, then some action is suggested. These conditions could be various different indicators within different ranges. We want the AI to come up with all of this. And the actions themselves could be things as simple as, I want to go long, I want to go short, I want to cover the short. Or they could be, for example, I want to go long, but I want to go long with a limit order at a certain price difference to the close price of the last minute. So all of that could be authored automatically by the AI. Now, to do so, you need to have this container. This is basically the grammar for your trading, your stateful trading system. And so this is that dartboard. So you're allowing the AI to throw darts and basically populate this with some trading strategy that's probably going to be very, very bad because you just use complete random functions to populate it. But it compiles. In other words, I can take this and I can run it on historical data and get an assessment of how good or how bad it is compared to others. And that's all we need in order to start. Then what we do is we go through the same process that I showed, right? You have all, the list of your rules, initially randomly generated, and then you go through your data set, historical data set, and get a fitness on them. Once you do, you can rank order everything and kill off most of them and take the ones that you want to use as parents and build these new rule sets and just cycle through this over and over and over again. So very simple evolutionary process. But through this process, we're actually authoring the system. Now you can take this, it's an embarrassingly parallelizable approach. So you can take this and you can run it on many, many, many compute nodes. In fact, beyond a single data center. AI is notoriously difficult to run beyond a single data center. You do need high bandwidth connectivity between the nodes, but in this case, you can actually do this. And have a coordinator where you kind of just have this list of the best trading strategies so far. You can do some very interesting things by, and I'm not sure if I have enough time to talk about it, but this scale, in fact, allows you to tackle very, very large search spaces. Somebody asked me, I think it was my co-founder, he asked me, put this in the context of the number of seconds from the beginning of time, or Big Bang. It's many, many factors larger than that, of course. And then you can have this system run, and occasionally you harvest from it. And that harvesting goes and runs against your unseen set, and you make sure that it is sufficiently generalizing. You use your eval set ultimately, and you go to live trading. So that would be one way of building this. And of course, I'm now going to, please don't use your cameras because I'm going to show you the rule set for such a system. That's right there. Joking, of course, but this actually was used for actual real trading of real money. So it passed all of those hurdles, this particular, what we call gene, this set of rules. And there's some interesting aspects, so I'll highlight a couple of these rules here. This guy is a buy rule, and this guy is a long position exit. You can see that, for example, it's using the concept of introspection. You can actually look at your own state and say, how much money am I losing right now? And if it's less than a certain amount, then do something. And it actually picks it up. What's interesting about evolution is that you can then tell how popular these indicators are, how information worthy they are. Again, look at the action here. It's not just buy, but it's buying using a limit order with a certain delta from the close price. And ultimately, a trader like this, one would hope, can trade at very, very good times for the stock and make us a lot of money. Not always. That's it. Thank you.